Hey there! Today, we will be discussing the process measurement unit 1, flow measurement. Introduction. Flow is defined as a fluid or known as liquid or gas in a motion. Flow measurement is used to ensure the process is at the design operating conditions and to control the quality of the product. Did you know? Flow measurement is essential for ensuring operational efficiency, maintaining safety, and achieving accurate control. Also can apply to gases, liquid, or even granular materials in use in sectors like oil and gas, water management, pharmaceutical, food production, and many more. Here's some key components of flow measurement. 1. Fluid type. The nature of the fluid, liquid, gas, or slurry dictates the method used for measurement. 2. Flow rate. This refers to the volume, mass, or velocity of fluid passing through a point in a specific time. 3. Measurement instruments. Devices used to measure flow include mechanical, electronic, or differential pressure-based systems. Here's the important one. 3 different flow quantities to be measured. The first one is the actual velocity at a given point, which is measured in meter per second. Second, the volumetric flow rate, which is measured in meter cubic per minute. And last, but not least, is the mass flow rate measured in kilograms per second. And next is measurement of flow in terms of volume. Volumetric flow rate measures the volume of fluid passing through a given cross-sectional area per unit time. Here's some formula to calculate the volumetric flow rate. So now, we proceed to the next point, which is measurement of flow in terms of mass. This refers to the mass of a fluid passing through a specific cross-sectional area per unit time. The Coriolis mass flowmeter is an example of an instrument that uses the mass flow rate. The unit of measurement in volumetric and mass flow rate measurement is using this SI unit. Here's some type of a flow meter and the application. A turbine flow meter is a volumetric flow, mainly used for liquid, used for gas as well. Next is Coriolis flow meter mass flow. It is mainly used for liquid, used for gas. Positive displacement flow meter is a volumetric flow, and used only for liquid. The ultrasonic flow meter is volumetric flow, mainly used for gas, used for liquid as well. And last is orifice flow meter that has a volumetric flow, and mainly used for gas and liquid as well. Here is the factor affecting the flow rate in the pipe. The first is caused by the velocity of the fluid. Beside, friction of the fluid in contact with the pipe. Next is caused by viscosity of the fluid. Finally, there is the factor of the density of the fluid. And now, we continue to the next subpoint. The nature of flow. Here's some basic laws govern the nature of fluid flow. The continuity equation, the conservation of mass, the Bernoulli equation. The continuity equation. This law covers the volume flow rate passing a given point in a pipe. The volume flow curve flowing through a pipe cross-section A in a unit of time is always constant if density is constant. As the cross-section becomes smaller, the velocity must increase to maintain the same volume flow rate. And next is the conservation of mass. This law can neither be created or destroyed. The total mass flow rate m at any given point in a pipe will be constant. This law has a particular significance for gas flows. And the last one is Bernoulli equation. The Bernoulli principle states that as the speed of a moving fluid increases, liquid or gas, the pressure within the fluid decreases. Hence, in Bernoulli equation, it states that the sum of all energy in the fluid flow, both kinetic energy and potential energy, remains constant regardless of conditions. The third subpoint is 1.3 Reynolds numbers. Reynolds number is a dimensionless quantity. It is used to determine if flow is laminar, transient, or turbulent. Laminar is when Reynolds number is less than 2000. The transient is when 2000 is less than Reynolds number and less than 4000. And last is turbulent. The turbulent flow is when Reynolds number is more than 4000. In practice, laminar flow is only actual for viscous fluids like crude oil, fuel oil, and other oils. And next is flow regimes. Laminar flow occurs at Laur, where viscous are dominant and is characterized by smooth constant motion, and the turbulent flow occurs at high Re and is dominated by inertial forces which tend to produce chaotic eddies, vortices, and other flow instabilities. Here is the fluid move in the laminar flow. The fluid particles move in well-ordered adjacent sliding layers. Here's the other one. The turbulent flow, which is the fluid particles, moves in all directions in a random manner and affects the flow streamlines in such a way that a uniform velocity profile results. And the last subpoint for today is 1 point for K factor. K number is the number of pulses expected for every 1 volumetric unit of fluid passing through a given flow meter, and is usually encountered when dealing with pulse signals. The unit used is pulses or volume, and the formula is flow rate. Q is equals to K factor, multiplied by output signal. The K factor can refer to different things depending on the context, but most commonly, it is used in these areas. K factor in flow measurement. In flow meters, the K factor represents the number of pulses generated by the flow meter per unit of volume, for example, pulses per gallon or pulses per liter. It is used to calculate the flow rate by converting the pulse output from the meter into a volumetric flow rate. The specific K factor is unique to each flow meter and is typically provided by the manufacturer. Here you can see some of the flow measuring devices. And thanks for watching.